Warning, the video you're about to watch contains mathematics at the level of college algebra and trigonometry. All material has an assumed prerequisite of both Algebra 1, which is elementary algebra, and Algebra 2, which is intermediate algebra. While some prerequisite topics are reviewed briefly, a more thorough review of these entrance topics can be found by searching the web.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes.
Hello, my name is Roy Simpson, professor of mathematics at Cosumnes River College in Sacramento, California. In this video, we're going to take the flip side of the previous video where we solved exponential equations. We're going to solve logarithmic equations. And this really does kind of throw a little wrench in the works, not too much of a wrench, but a little bit of a wrench into the works here. When you're solving a logarithmic equation, they usually come in one of two flavors. The first one being like this, where every term is a logarithm. The second kind is when you have a term that's not a logarithm. So that kind of breaks the world of solving logarithms into two pieces. Now, is that absolutely true that there's only two kinds of logarithmic equations? No, there's a whole bunch of types. But in general, you have these two basic families. Something you need to be highly aware of when you're solving logarithmic equations. The logarithmic function has a domain of only positive real numbers. I say only, but there's an infinite number of them, so you have a lot to choose from. But the reality is, log of something requires that something to be positive. So you will often, actually, when solving logarithmic equations, you will often reach solutions that will not work. You get a solution like, let's suppose when we solve this, we get x equals -3 as a solution. If that were the case, I know it doesn't work because one of my terms cannot take a -3 as its argument. So be highly aware of that. When you solve a logarithmic equation right at the beginning, just tell yourself, check solutions. Because if you don't, you will likely be wrong. You don't want to be wrong. So, all right, so let's go ahead and solve this. How do you go about solving this style of logarithmic equation? Well, use the property of logarithms. We're adding two logarithms right here. Let me highlight that. So we can use the property that says log, let me write this down, of m plus log of n is equal to the log of their product. So that's what I'm going to do here on the left-hand side. We get the log of x times x minus 1 is equal to the logarithm of 3x plus 12. Actually, to be honest with you, you don't have to go any further than this, because once you have two logarithms equal to each other, you can set their arguments equal to each other. That is, you can set x times x plus 1 to equal 3x plus 12 and solve. So basically what you're doing is you're raising both sides base 10. Let me say that again. If you don't like the idea of me just saying, oh look, their pictures are identical, let's go ahead and erase the logs on both sides. If you don't like me saying that, then we don't have to do that. We can go ahead and bring all that stuff back. And I could say instead, raise both sides base 10. If you raise both sides base 10, we can use a property of logarithms that b raised to the log base b of x will return x. So 10 raised to the log base 10 of that picture will just return that picture. And that's a different argument, but kind of leads to the same thing, so that we have x times x minus 1 is equal to 3x plus 12. And at this point, it's an old school algebra problem, right? Totally do this. X squared minus x is equal to 3x plus 12. Subtract 3x and 12 from both sides, so x squared minus 4x minus 12 is equal to 0. And hopefully that factors. It looks like it does. X minus 6x plus 2 is equal to 0. And that tells us that either x is 6 or x is 2. Negative 2. I looked away from my paper as I was writing. Okay, so those are our two possibilities. Now you're going to check those. I always kind of check the negative one first. So I'm going to look at this guy. The only reason why is because negatives and logarithms don't play well together. It doesn't mean, by the way, just because this is negative does not mean that you automatically get to throw it out. You have to check. So I'm going to go all the way to the beginning, the very beginning, the top question. And I'm going to say, could I plug a negative 2 in there? And the answer is, heck no, you cannot do that. So that is an extraneous solution. I should probably write that down. That means basically that we have a solution that was created that should not be there. It's a fictitious solution. Now we'll try the x equals 6. And I'm circling it in green because I think it'll work. So if you look at the original equation, could you plug 6 in there? Yes. Could you plug 6 in for x here? Yeah, it'd be a 5, 6 minus 1. And could you plug a 6 in here? Well, 6 times 3 is 18, plus 12 is 30. Yeah, I could totally do that. All those are positive arguments. So it does look like it will work. You might want to just double check by looking one step below, but generally speaking, if it works in the top equation, it'll work. But I'm just going to double check here. Again, if x were 6, you'd have 6 times 5 here. And this would be 6 times 3, which is 18 plus 12 is 30. And so you have 30, 30, log of 30 should equal log of 30. That's good. So, yep, that's our only solution. And that's all we were asked to do in that problem. Solving logarithmic equations just has an extra little step of checking our solutions. Notice we did get an extraneous solution here. Very common to happen that way. Now here is the second style of equation that you would see with logarithms. It is an equation where not every term is an actual logarithm. So one of our terms is just a constant. So that doesn't really hurt us. It's just that you want to use the properties of logarithms if you can. So I'm going to move everything with logs to one side. So I have log base 2 of x squared minus 6x minus log base 2 of 1 minus x. If you're wondering why I would do that, it's because I want to glue together all my logarithmic terms. And we have properties that allow us to do that. So this will imply log base 2 of, remember this is positive, or I'm sorry, not this is positive, but this is a positive logarithm right here. So this stuff will be in the numerator, x squared minus 6x. You should know that from the previous video that we did. And this coefficient's negative, so therefore this junk right there is going to be in the denominator. And look at that. Pretty awesome. And now we'll go ahead and technically you should do a little bit of algebra to see if 1 minus x can divide into x squared minus 6x, but I know it won't, so I'm not going to bother. I will just use the circular argument. 2 raised to the third power should equal the inside. Essentially, you trade out this logarithmic equation for its exponential equation counterpart. So 2 to the third, which is 8, should equal the interior, x squared minus 6x over 1 minus x. Now remember what I mentioned about logarithmic equations. You'll have to check your solutions. In fact, I should have written that at the top, check solutions, because the reality is it's often forgotten. We often solve and then run away from a problem, but it's very important. There's a lot of places here where we can have issues. For example, one issue would be if x were equal to 1, we'd have division by 0. That's a problem. So let's go ahead and multiply both sides by 1 minus x to get rid of the fraction. So we get 8 minus 8x is equal to x squared minus 6x. We'll add 8x to both sides and subtract 8 from both sides. So we have x squared, what is it, plus 2x, and then minus 8. And then hopefully we can factor that. I think actually it factors nicely. X plus 4, x minus 2 maybe? Perfect. And now we know our solutions. Either x is negative 4 or x is positive 2. Again, because this was a logarithmic equation, you will have to check both of these. So I'll start with the negative one. Not that that one automatically gets thrown out, but it's probably a good idea to check it. Not just a good idea, it's required. So again, we're checking negative 4. So if you plug negative 4 in, you'll get 16 minus 6 times a negative 4, or plus 24. That is okay to plug into a logarithm. We're fine. The question is that equal to 3 plus log base 2 of, again, 1 minus a negative 4, or log base 2 of 5. Now, the fact that all the arguments here are positive is very, very encouraging. But I still, since it's simple arithmetic here, I still want to go ahead and check all this. So I'll just say that's log base 2 of 40. I'll subtract this log base 2 of 5 from both sides. And the question is that going to be 3? Log base 2 of 40 minus log base 2 of 5 is log base 2 of 40 divided by 5, or 8. Is it true that 2 raised to the third is equal to 8? And the answer is heck yeah, it totally is. So that is done. By the way, I erased very quickly just because I am going to check the second solution, but at least we know, and you can also pause the video and come back to it and see, but at least we know that this checks out. Now we're going to try the positive 2. And positive 2, actually I know is not going to work, because if you plug 2 here, you'll have the log base 2 of 1 minus 2, or negative 1. And immediately, I know I can throw out that solution. So I'll just cross this out. It's extraneous, and we are done with that problem. In fact, really, there's not much else I can say about solving logarithmic equations, because you've already done it in your previous course. If you need a deeper dive into solving logarithmic equations or exponential equations, you should see my series on Algebra 2, which introduces the concept and goes through a lot of problems, no, I shouldn't say problems, a lot of exercises, and builds the theory. But at this point, it's assumed you know the theory. There's no reason for me to do 1,000 examples. 2 suffices because it covers all the bases.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes obstacles getting in our way. Cause affects more than we can sometimes see. Things for what they are and work together until you feel at peace. Says, listen close, don't talk too much that isn't kosher. You may really hurt inside. It doesn't justify you to speak too loud and cry. Don't whine, just